All right, guys, so keep in mind that these first three problems are pretty much what we did yesterday. We started off with the basics yesterday, the basic product and quotient rules of exponents. And today we're just going to build on that. So, if you know how to apply the three rules in these three problems, you're going to be doing the exact same thing for each of the problems that we do today, but it's going to be a little bit messier. So, today is not really about concentrating on the math per se. It's more of how to work through the math to apply these very simple rules. Because at the end of the day, all you're really doing is adding and subtracting numbers that are probably the biggest number you'll do is probably like 12 or 15. So let's make sure that we have the good foundation, we understand the rules, so when it gets messy, we know how to apply them correctly. Now remember here that all these bases are just multiplying each other. That is pretty much what exponents are. They're just repeated multiplication. So when they ask you to simplify the following, they're literally just telling you to, hey, rewrite this in a simpler way. Now, the way I like to do it, first, I like to see all my bases. I even underline them so that way I can see a visual. And then I go back and I write an exponent of 1 for each variable that doesn't have an exponent. And then I go back and I'm like, okay, what is something that I can multiply or simplify? Now remember that these are just numbers that are getting multiplied. 2 times 3 is just a 6. So I'm going to go ahead and simplify those. I'm going to cross those out so that way I can visually see that I've already dealt with those. Then I'm going to go to the variables. I notice that I have a base of A. Am I multiplying that A by another base of A? And the answer is yes, because notice that these two are just multiplying. When you multiply two like bases, in order to simplify, all you have to do is add their exponents, which in this situation, 1 plus 5 is a positive 6. Now, as I was walking around, I saw some students write down a to the 6, and then they would multiply it by 6. Now, this is inappropriate because you're always supposed to have your coefficient out in front. So make sure that your coefficient is out in front, so that way you don't get any of those easy points gone. All right, so we know that when we multiply two like bases, we're going to add the exponents. Now, when we are dividing two like bases, we're going to subtract them. Now, make sure that you're training your mind that when you see a fraction is just a division. That's literally all it is. So if I look at this, I have a base of C divided by a base of C. So I know I'm going to subtract the exponents. Now, where your base belongs is going to take a little bit more thinking, and it's actually pretty straightforward because all you have to ask yourself is, hey, where are there more C's? Where are there more bases? AKA, which one has a bigger exponent? Now, you have 10 C's on top, 6 C's in the bottom, so you know that your base is going to end up on top. 10 minus 6 is a positive 4. Now remember that if you don't have nothing in the denominator, that's okay. You don't have to add anything. Let's go ahead and do the next one. Now notice that this is, again, kind of the same thing. I can see that I'm dividing two T's, but I don't see an exponent here. So I'm going to write a 1 there just to kind of visually show myself that, hey, this is T to the 1. Now, again, you are dividing two like bases, so I know I'm going to subtract the exponents. But where are there more T's, in the numerator or the denominator? Remember, the denominator is the bottom, the numerator is the top. So what? The denominator, right? So you know that your variable is going to end up in the denominator. And then you just do the math from biggest to smallest for subtracting. 11 minus 1 is 10. And then you don't have anything in the numerator. Now, you always have to have something in the numerator. If nothing's there, write down your 1 to kind of have it as a place value, and then we are pretty much done. Now, again, if you know how to do these three rules, that is all we're doing today, but we're going to do it in a little bit more messy way. So if you build the foundation, if you understand this, you'll notice that today is a little more straightforward. Again, it's just a little bit messy. And let me show you what I mean by that. So these are two very stereotypical problems, what I define as messy. Notice that there is a lot of things going on. There's variables, there's constants, there's a lot of stuff going on. But always revert back to what you know. Don't let what you don't know get in the way of what you do know. And one thing that we do know is that notice that all these bases are just multiplying each other. That's all they're doing. They're just multiplying each other. So if you look for the constants, just the numbers, you know how to simplify that. What is 4 times 2 if all those things are multiplying? Is there any way we could simplify that and actually do the mathematical operation? Yeah, right? Because what is 4 times 2? 8. Now, I highly recommend, as you simplify away, to cross them out, because you'll notice as you go on, things get a little bit cleaner. You can see what you still have to simplify. Now, notice that here, my next variable up is a z. Now, remember that you could only simplify the two like bases. So what I'm trying to get at is, okay, I know I have a base of z. Is there any other base of z that's multiplying that z? And the answer is yes, because if you look at that very z in the end, it's a z. Now remember that all these numbers, all these bases are just multiplying each other. If you multiply two like bases, your z stays the same. What do you do to its exponents? You add them, right? Just like before. Don't let the mess get in the way of what you already know. When you multiply two like bases, you add their exponents. This z had an exponent of 1. This one had an exponent of 2. So 1 plus 2 is a positive 3. I'm going to cross those out just to kind of organize myself and make sure that I am combining and not leaving anything out. And now you can see that clearly those two y's are standing out. Those two y's are getting multiplied. So in order to simplify these, you're going to add their exponent. So 4 plus 3 is a positive 7. And you can finally see that there is one thing left over, is that x to the 4. Now, is there any other base of x there? No. So that means that it's just multiplying. So you're just going to write it down just to kind of tell the reader, hey, we're still going to multiply by x to the 4th. Now, there's nothing else you can simplify. If I look at my constants, the numbers, there's no other constants. There's only one z base here. There's only one y base. There's only one x base. So you're pretty much done. Now, keep in mind that your constant always has to go in front. Technically, the answer keys are always going to have your variables in alphabetical order. I really don't care about the variables being in alphabetical order. As long as you're adding and doing correctly, I'm okay with that. But I do care about your coefficient being out front. It's a very, very important habit that you want to get used to. So as I go on, I will grade you on the coefficient being on front, but the alphabetical order of the variables, I don't mind. And of course, you have to simplify it. All right, so try number 2. I'm going to zoom up and might as well give you a shot at number 3. And we're going to skip out number 4 today just for time's sake today. All right, guys, so let's finish 2 and 3. We'll do some division, and then after that, it's all about you guys finishing your practice. So what I like to do is just kind of first understand what the problem is doing. And what I'm doing here is I'm just simplifying. I'm making something that's complicated look a little bit simpler. Now, all these constants are just multiplying each other. All these bases are multiplying each other. So I know in the back of my head that, okay, I'm just multiplying. There's nothing really too crazy about it. That's all that's going on. Now let's start with that 2. This is just a constant. Is there any other constant anywhere in the string of multiplication? No. So I'm just going to bring it down to continue my other simplification. Now I already dealt with the 2, so I'm going to cross it out. I notice that I have a variable of x next up, but there's no exponent. So I'm going to go ahead and write a 1 there. So that way I can visually see that, hey, this is x to the 1. Now I notice I have x to the 1 and x to the 3. If I were to combine those, I'm going to add their exponents. 1 plus 3 is a positive 4, so you end up with x to the 4. And you just keep going. You just do each variable one step at a time. Notice here that this y is raised to the 1. Where is there another y? Another y here. It also doesn't have a variable, so I'm going to put a 1 there. And now I can go back and be like, okay, when I multiply two like bases, I add their exponents, so 1 plus 1 is a positive 2. Cross them out afterwards, and then finally you can see now that you only have those z's. So if you were to combine those, you add their exponents. 4 plus 3 is a 7. So you can check back and be like, hey, is there anything else I can simplify? And you can see that there's nothing else. There's only 1 x, 1 y, 1 z, 1 constant, and you're ready to go. All right, so let's look at number 3. I can see here again that there's a lot of things going on, and you'll see that most of these problems are a little bit messy, but just take one thing at a time. All these are just multiplying each other. Notice you have a constant of 2. There is no other constant, so I'm just going to rewrite it over. Notice you have a p to the 1. Is there any other p's? Yeah, they're right there. So I'm going to add their exponent, so I end up with p to the 4, because 1 plus 3 is 4. I have an r to the 2 and r to the 2, so that's going to be combined to be r to the 4, because again, add their exponents, you're multiplying two like bases. This q to the 2 has nothing to do with anything. It's just going to follow along, watch the show, and that's it. That's as simplified as it can get. Just a friendly reminder, make sure that your constant is out in front, aka your coefficient, and your variables, I don't mind as long as they're there and they've been combined correctly. Okay, So this is all multiplication in the messy way. Let's do some division and we'll call it a day after that. All right, as we look at numbers 5, 6, 7, and 8, there's a lot going on. But keep in mind that you're just applying a very simple kind of concept over and over. So always keep that in the back of your head that you're really just organizing. Today's all about strategizing and organizing in order to make sure that you don't make these little mistakes. Now remember that whenever you have a fraction, all you really have is a division problem. And if we divide two like bases, what do we do to combine their exponents? When we multiply, we add. When we divide, what do? You subtract them. So keep that rule in the back of your head that while you're doing this, you're like, okay, I'm going to combine like bases, but I'm going to subtract their exponents in order to do so. Now, let's start just like before. I'm dividing something by something. Notice that this is just 2 divided by 3. Is there any way, shape, or form that you can reduce 2 over 3? Is there a number that divides 2 and 3 that's not 1? No. So there's no way you could reduce that. You can't divide it, so you're just going to rewrite it as 2 over 3. Keep in mind that I'm leaving what's in the numerator and what's in the denominator and the denominator. Now that I simplified those, I'm going to cross those out. Notice I have a base of x on top, a base of x on the bottom, aka those bases are getting divided. Now, just like we said, when you divide two like bases, you subtract the exponents. Just like our entry task, where there are more x's in the numerator and the denominator. You can see here that the numerator has 3, denominator has 2, so that means that there's more on top. 3 minus 2 is 1. Is it really absolutely necessary to write this 1? No. If you do, I'm not going to mark you wrong for it, and if you don't, I'm okay with it as well. All right, let's look at our y's. There are 3 y's on top, 2 y's in the bottom, so I know that there's going to be more y's on top. 3 minus 2 is 1, so just like before, there's no need for that 1. I'm just going to go ahead to my next one. Now, this is where it gets a little tricky because now I'm going to simplify these z's. Where are there more z's, in the numerator or denominator? The denominator, so you know that that base is going to go to the bottom. 4 minus 3 is 1. Do I really need to write it? No. So go back, you can double check to see, hey, there's only 1x, 1y, 1z. The 2 and the 3 is just 2 over 3. There's no way, shape, or form to divide it and get a whole number or to reduce it, so you are done. Try number 6, and then after that, I think we have a pretty good foundation. That way you guys can practice on your own. So you don't have to do 7 or 8. I can help you guys a little more individually if you need a little more practice. Just try number 6 real quickly. Oh. See, I said you. I hope that 4J to the 4th. What are you trying to look at? That's all I can do. Right, now you have the J's. Does J have the 1? Where's the J's go? Now let's do math part. Remember, we're dividing 2 like bases. What are you going to do here? So you're going to subtract her out. Great, there you go. baby. All right, guys, so let's go over this problem really quickly, and then we'll just have practice for you guys. So if you look at this guy here, again, we're dividing, right? So let's start with the coefficients. And we have 4 over 2. Now, can you divide 4 by 2? Yeah, right? 4 divided by 2 is 2. So I know that's going to divide it by 2. I'm going to cross them out just to kind of show that I simplified. Now, I notice I have a j to the 4 and a j at the bottom. Now, just because I'm a visual person, I'm going to go ahead and write those exponents of 1. Now, there are 4 j's on top, 1 j in the bottom. So you know you're going to have 3 j's on top. So j to the 3 stays on top. What I mean by top is the numerator, right? Now, let me cancel these out. I can see that I have a k to the 3 and a k to the 1 in the bottom, the denominator. So I'm going to subtract those exponents. More k's in the numerator, so you know you're going to end up with k to the 2, because 3 minus 1 is 2. Now, notice that you have an h to the 3, and there's no other h's. So unfortunately, it has to stay in the denominator by itself. And that is exactly how you simplify. There's nothing else. Notice you can always double check back and be like, okay, I have 1j, 1k, 1h. Everything is simplified. And I'm good to go. That's it. So the rest of the time is going to be for you guys to work on your guys' homework. There's only 10 problems, so I feel like you guys have more than enough time to complete this in class.